Hi all, this time we're going to learn about a very important piece of kit in the programmer's arsenal, which is variables. Okay, so we're going to learn some keywords, const, let and var. We're going to learn about the scope of variables, which is a very important concept, and we'll see some animations that animate themselves rather than just relying on us moving the mouse pointer around. So in the previous slides, we saw an example of a button or a rectangle that had fixed numbers to represent the size. But we can actually do a bit better than that by defining symbols which represent the values, so that the code becomes more readable and more maintainable when we want to go and change, for instance, where the rectangle is. So to do this, we're going to use variables. In JavaScript, which is a bit of a moving target, people keep changing it. There are 4 ways to actually create something which you might loosely call a variable. 2 are new and preferred, and 2 hang around as a legacy that we would rather not have to have. Okay. The first one creates constants as opposed to variables. These are things that behave in all ways like variables, except their values are fixed once they've been given a value. Here we're giving the constant x the value 120 and it will have it forever. Here we're giving a variable x the value 120, but we can change it later. And both of these are variations on giving on variables, but they're the old ways. So constants are really useful. We use them in just about every language I can think of. We want to use a symbolic name bound to some value, and then use that name through the code so that it's much more readable. So if you see a number in a statement, it's hard to figure out what the meaning of that number is, but if it's got a nice name, it's always better. If you want to change the value, then you only have to change it in one place, and all the code will then adapt rather than having to hunt through and find all the places where that number might be important and change them all. Okay. Now, the names that you choose for constants, they're identifiers, and theoretically you can use all the rules for identifiers. They can start with any kind of letter and then have underscores and dollar signs. But by convention, if we want something to be a constant and not change, we generally give it a name which has got all capitals, and that's where the underscores become useful to separate words. Okay, whereas for normal variables we would use not necessarily all constants, we might use capital letters in the middle using camel case. Okay. All right. So declaration of variables. Variables must be actually created before you can actually use the value in them. And so, for instance, I can say print x after I have given x a value, initialized it, by giving a value 5. So if I say const x equals 5, sorry, I should say gets, that's better. Const x gets 5, then we can print x is fine, but if you do it the other way around, try and print x before x is actually bound to this value, you're going to get an error. Okay, you'll probably get told that it's the value that you're seeing is undefined. So scope is the visibility of a variable within the code. Okay, so we've seen some curly braces. Our functions start and finish with curly braces, and we've also seen them in the context of if statements and else blocks. Okay, so curly braces are used not just to group lines together, but also to define scope. Okay. So if you are using const, the rules are a little funny. We've defined x previously. If we define y inside this if statement, then the scope, where you can see it, in fact, how long it actually lives, is between where it's initialized and the next brace. Okay, so const y gets 2, you can print y here, but in this example, if we declare and assign y gets 2 in here, after this brace, so we've exited this block defined by these braces, then y in fact no longer exists. It's out of scope and doesn't even exist anymore. Okay, so const works this way, so does let. Let works the same way, and the reason we don't use var anymore is it works slightly differently. Now, global variables, we're talking about variables introduced with let, or even constants that are defined outside of any function, we refer to as global variables. The ones that we declare inside functions are called, you can guess, local variables. Okay, so global constants and variables are accessible anywhere within the JavaScript. In fact, they're initialized as the first thing the program does. So it doesn't much matter what order you put your global variables and functions in. They'll all be initialized first. Okay. So generally speaking, global variables, things that are actually changeable, in other words, not constants, should be avoided as they cause code coupling, which means one piece of code depends on another piece of code. And if one piece of code depends on another piece of code, then you can't sort of necessarily cut that piece of code out of one program and paste it in the other and expect it to work anymore. Also, global variables within just the one program cause the possibility that one function might change a variable that another function actually relies on, and maybe that is not what you expected, and maybe that's an introduction of a bug. Okay, and it's caused by one function having a side effect on some other function. Now, so there is a downside to these global variables, but on the other hand, they're sometimes the only way to do something, so we have to, that's why they're in the language at all. Okay, so especially when you want to do animation, we will need our global variables to hang around between function calls, preserving the value they have, and that means we must have some global variables when we want to do animation in P5. Now, global constants, they still cause some of this coupling, but it's not particularly unsafe. So in my programs, I try and have as few global variables as I possibly can, but I don't mind having plenty of global constants. So here's some constants examples. Okay, so I'm going to define a rectangle with some constants, and I might declare these constants outside of any function. It's okay. And so const rect x is the x, and const rect y is the x and y of a rectangle and their width and height. Okay, notice I'm using all shouty caps because I've declared them with constants, and that's a reminder when I see those names used later on that they're constants and not variables. And I can compute other constants based on these other constants. So I can take a lot of the maths that I might otherwise be doing inside my draw function, for instance, and take it outside and do it once in a convenient place and make lots of handy, convenient names which really describe their purpose rather than having lots of just raw numbers scattered through the code. Now, these lecture notes were not prepared by me. I fixed this slide so it used all capitals. Later on we'll see some examples where they don't use constants so much and they haven't bothered to put them all in shouty caps. I couldn't fix them because they're done with images, not just text. So apologies for that. Okay, so the let keyword is for defining variables, okay, as opposed to constants. Okay, now, as I said before, we're going to have to have a few of these global variables so that each time the draw function gets called, it can use a slightly different value of those global variables. So in each draw call, we can use the values of the variables, and then as the last thing we do in the draw call, we change or increment the variables by small amounts so that the next time the draw function is called, we get a different result. Okay, here's an example of a very simple thing. It's a rectangle that's going to move from left to right. So we declare a global variable for the x, okay, and that's going to happen just once when the program starts. And then function draw, of course, gets called 60 times a second, So it's going to draw a background, and then it's going to draw a rectangle, but the x value is not fixed anymore. It's actually this global variable. So it will, the first time, draw it at x equals 0, but then the next thing we do, okay, or the last thing we do inside our draw function is change x, okay? So that when the function comes back and is called again by p5 in a 60th of a second, then the x value has increased by 5. So the rectangle will be drawn in a slightly different place. We won't see the old rectangle because we drew a background again first. So we should see a rectangle sliding from left to right. Okay, and this example doesn't seem to animate, so but that's the idea. Okay. Now, in this example here, we've actually animated it and stopped it from completely leaving screen because the animation part, the part that actually changes the x value, is inside the an if statement which stops x getting too big and taking it off screen. Notice here are these constants that don't have all shouty caps that should. Okay. All right. So if we don't redraw the background every time and draw something, we'll see multiple ghosting images. Okay. If we change the increment on something, it appears to move slower, so the animation looks smoother because each successive ellipse is closer together. So incrementing variables is something we do a lot, and there's actually some shortcuts in C-like languages that are often used. Okay, so instead of writing a full assignment statement that says x gets x plus 1, in other words, we're changing the value of x to be a new value which is stored back in the value, there's a shorthand which is x plus plus. Okay, and if you've ever heard of C++, it got its name because it was an incrementally better version of C. Okay, so C x plus plus is a shorthand for taking the old value of x, adding 1 to it, and putting it back in x. There's also another shorthand notation which uses an assignment operator which has got a plus sign built into it. Plus equals is equivalent to x, the new value for x gets the old value of x plus 5. Okay, and so that means you can increment by whatever value you want. Similarly, there's also minus minus, which will subtract 1, and minus equals, which lets you subtract whatever you want. Okay, so then we have this bounce example. Now, so what we're doing here is we're making the increment value actually something which is a variable itself. Okay, so if our rectangle reaches the right or the left, you'll see that the increment value, which we'll call velocity, which is another word for speed, but with direction, okay, is flipped to its negative. So as it's moving left to right, the value will be positive, as it starts out here positive. And when it reaches the right-hand side, we flip it to minus itself, which will so we flip it to minus 5, and so now the box is heading right to left until it reaches the left. Okay, so let's have a look at this complicated if statement. If x is greater than or equal to width minus rect width, okay, or x is less than 0, so if the x of the box is less than 0 or greater than what you get if you take the whole box here minus, okay, the width of the box, it's time to turn around. So we'll flip that velocity. Okay, either way, we then say x gets x plus velocity. Now that, remember, that might be a negative value, so basically you're taking 5 away. Okay, moving in two directions at once. Well, you can have two velocities. You can have an x velocity and a y velocity, or you can just increment by 1. And so in this ellipse here, each time we draw, we're incrementing x and y, so we're moving diagonally because it moves a bit in the x direction and a bit in the y direction at the same time. Okay, changing colors. Another thing you can animate, not just the position of something, you can animate how it looks. So in this case, the fill is what's variable. We start off with fill equals 0. The R value equals 0. It's the amount of red you have. Okay, and now we're filling, each time we draw, we're filling with red, our amount of red, and 0 and 0, and drawing an ellipse with those conditions, and we're drawing it at mouse X and mouse Y, so we can move the mouse around. So we're basically painting, but as each frame happens, we're getting more and more red, so it's progressing from black through to bright red. Okay. Alrighty. Now, let's look at some of the legacy ways of doing things. The keyword var does the same job as let, but with a slightly different, I'm going to use the word semantics, a slightly different meaning in the program. And the difference is to do with the scope. Now, remember before, if we did an example with const, if we declared const y equals 2 inside this block, if we then tried to use y, we had an error or undefined. The same rules work with let, but with var, which is the old way that let replaces, the semantics are that y would still be in scope here, because var says the scope is limited by what function it's in, not necessarily by what block it's in. Now, that was the original decision they made in JavaScript, but it's not consistent with the way it works in modern versions of C, Java, and other sort of similar languages. So let behaves more like other languages, and so it's going to be preferable. Okay. If you declare a variable without a keyword at all, okay, so in this example, we've got x declared somewhere if x is less than 5, and we've got this brand new thing, never before seen, y gets 2, well, you can still, it's like you've used var, except that the scope of it is not now the function, it's a completely new, totally global variable. And remember, we don't want as many global variables as you might be able to do, because they have problems with side effects and so forth. And so it's really a bad thing to do. So you've got to make sure that whenever you create a variable, a new variable, do it using let. And one source of error is probably you're creating global variables because you forgot to use const or let or something like that. So summary. Okay, we have var and no keyword at all, avoid them. Okay, we have let and const. Use let as much as possible only for local variables, but for animation's sake, we need some few variables to be global. As much as possible, use const. You can use it liberally for global variables, and you can use it for local variables. If a variable only gets one value and you're not going to actually give it a change, it doesn't matter whether it's global or local. Use const in preference to let. You may find that let and const aren't supported in the particular version of JavaScript that's running on your browser, in which case you have to go to the other ways. But I think you're better off get a better browser. I think you'd be very hard pressed to find a browser these days that doesn't understand let and const. And if you are using a browser that doesn't support let and const, it's probably got heaps of security insecurities, and you're better off taking it out and burning it logically. Okay. All right. That's it. See you next time.